subtitle for this. Okay, okay, perfect. We got the automated recording notification. Perfect. All right, so the subtitle is Exploring ROS, the Basics, Simulation and Prototyping. So I was going to give you like a little background story of how got started into ROS. So, all right, so I just graduated from the School of Science and Technology at Atlas University in Lagos, Nigeria. So my major was mechanical engineering, but I focused on robotics and automation. So this is my profile. So this is me in the middle here. So I was I got an opportunity to represent Nigeria in a competition organized by Airbus. So we went to build small robots to explore Mars. This was about 6 years ago. So this was 2015. This was my first robotics experience. Having to interact with robots. So we built basic simple robots. And it was really, really interesting because my team, we developed something very, very simple and we, got the best position. Yeah, and it was some of my friends as well. Yeah, this was me in secondary school. And this is our makerspace competition at my school where I organized this. So we basically use Arduino, it's the SSD makerspace event. So and it has been really nice trying to get students to sort of get interested in robotics and just try to build stuff together. But I wanted to do something more complex, so that's why I went into Rust. So this is me in I think 2020 2022 or three. Yeah, I was in Senegal. Yeah, I got to represent Nigeria in Senegal, Dakar, at the Pan African Robotics Competition. So this was my first exposure to ROS, and I was very lucky to have learned under Professor Kenneth Vanzi. So it was very, 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 very interesting. I was really, 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 really mind blowing, and like I had to, learn a lot of things. So it's gonna be it was really, 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 really interesting but challenging. But I think with all the exposure I got, I sort of got the interest to move into robotics deeply from my first back experience. Yeah, and lucky for me, so the competition was about controlling agricultural robots to be able to move autonomously and also navigate and also detect weed as it moves along. So, and it was sponsored by Google MathWorks. Yeah, so I just wanted to, I don't want to mention some softwares you might not know. So I just wanted, does everybody know MATLAB? If you know MATLAB, raise your hand. MATLAB, just React. If you heard of MATLAB, MATLAB, MATLAB. So MathWorks is the company that's okay. Thanks, John, that sponsored MATLAB. So, and this is me and some of my teams, yeah, in Senegal. So the company that gave us the robot was K2. It's actually based in Senegal. They do underground robotics and mobile robotics. And so we did a computer vision task. So you have to train a model to be able to detect the weed and also a fruit. So the task was to detect tomatoes. So I was able to work with my team to do this. So and also lucky for me, this was my first time applying on global TV because of robotics. I was featured by Al Jazeera during the competition. Yeah, it was really, really fun and it was great exposure. And through this, I've gotten lots of opportunities. And this led to me working in a company in the US. This was my first big internship in robotics. So I was able to work with Orange Food. It was really, really amazing experience. This was my first big internship. Now today I'll be talking about ROS. So and I'm not gonna be doing a lot of talking, so I would expect some of us here to share the experiences. I'll be asking some questions. So it's gonna be very, very interactive, and I want you all to discuss and enjoy the webinar together. So ROS is an open source robotic operating system. So operating system, a lot of people are like, it's an OS, but why doesn't it stand alone, right? Like, operating systems, the very popular ones are like Windows, the Macintosh, and you don't have ROS. So ROS, robot operating system. So like, why is it an operating system when it needs to be installed on Linux, on it. You get so it's there's a lot of questions, right? And I just wanted to ask, does anybody know why the actual and will I say software you can categorize ROSs? Does anybody want to ask? So let me just give some hints. So just give options. Okay, you can put your questions in the chat. If you want to answer, you can also answer in the chat. So is ROS a middleware? So it's ROS an actual operating system or middleware? So I just wanted to ask, does anybody know the answer to that? Is he a middleware or an actual operating system like your Windows computer? Does anybody have an answer to it? It's a middleware. Oh, perfect. Thank you so much, Bina. Yeah. So, do you want to answer? You can just unmute. I actually don't mind. I have ample time for this session, so I actually want it to be very interactive so that we can all understand what ROS is and how it works. Does anybody want to unmute and just speak about this? You know, anyone? Okay. Let me check the chat. Okay. So it's a middleware. All right. So maybe during the Q&A we'll have more time to interact. But so I think the reason why ROS is given the name operating system is just I think for the catch, right? So it's actually a middleware. It's being used in different operating systems. So if you check the resources I sent, you see I sent some videos and there's a way to install ROS now on your Windows computer via VS Code. And today we'll be using VS Code to sort of run the applications and packages you'll be running today. And so ROS is actually the set of libraries to use the IP build robot applications across a wide of robotic platforms. So it was actually developed originally in 2007 at the Stanford Artificial Intelligence Laboratory, and development continued at the Windows Garage. So I think they gave it the name ROS just sort of just for marketing, right? So that people can sort of use it. It's not a language. It's not a simple software. It's actually a middleware. So that's the right time I wanted to point out. Now, okay, so we'll go to the next slide. So what is ROS? I'm still trying to talk about what ROS is. So when I was first introduced to ROS, I think it was during one of my course, Introduction to Robotics. So and it was very not interesting, yeah, and I didn't enjoy it because I was just thought about a lot of things, a lot of will I say sub definitions about ROS. Like ROS is middleware, it is modular, it is user friendly. Is it user friendly? I'm not sure, but now I believe after this workshop, ROS should be user friendly to a lot of people, yeah. And a lot of developers, a lot of companies use ROS because it's very adaptable, it's flexible, and it has a lot of things. So I got this picture that sort of explains what ROS is. So this is actually ROS one. So in ROS one we use ROS master, but I will explain the old term of ROS master. Then it's in the ROS two we actually have the DDS. So, but I just wanted to explain some things in ROS. But as we move further, you would sort of understand. So in ROS we have things called messages. So I just wanted to point this out. So when you see them, it doesn't appear strange. Then we have what we call packages. So we have things called ROS packages. Then we have nodes, right? Then we have libraries, services, and stacks. Okay, next slide. So what's a robot? So when I was very little, I think about 9, I used to think about robotics in general as just humanoid robots, right? So when you have a robot, you think about a robot in human form. But now you can have robot in different forms, right? You can have mobile robots, you can have UAVs like drones. So the whole concept of robotic is it's actually a, a a component or a machine that can sort of sense, think, and act. So when we say sense, it means it has some components around it that are called sensors. So a sensor sort of picks a signal in the surrounding, right, and sort of converts the signal. It could be a physical signal, it could be vibration, it could be, it could be anything. It could be light, it could be, it could be obstacles, it could be anything. So it senses that thing, then convert it to a sort of digital code for the computer to basically manipulate, process, and make sense of it. Then think, right? So think this is where human comes in, right? We have to sort of build algorithms. We have to build control processes. We have to build. That's what you have. What kind of control method are you using? What kind of control method? So it's what the human comes in, right? We sort of program. So a robot can't just appear and say, "Oh, I am a robot." Obviously, it's not possible, right? There has to be some sort of human contribution to robotics, right? So robots just form on its own, but I know we are getting to a stage whereby robots will be built by robots, right? So that's sort of AGI, we are not there yet, but I believe in a couple of years we should be at AGI. So, but so ROS is more like the software that enables robotics application, right? And it's very, very easy to use. It's, community driven. Yeah, and it's very. A lot of people say ROS is challenging, but I'll say ROS is simple. When you give it the time, you have to sort of dedicate so much time to, learning ROS, and it's very interesting to use. Challenging, but definitely interesting. So this is the summary. So you have sense, then you have process. So process now it's more like trying to enable the robot to think. So like what kind of programming, what kind of analytics, what kind of algorithms are you designing? So control, basically working with the process, right? Then you have setup. So rough, it's like it's doing everything. So you just think about it as the structure that enables robotics to sort of derive the software for control and process. So it means I run all my algorithms via ROS. So if I wanna build a simulation project, or if I wanna build a drone, for example, I can design the drone, and sort of implement a software on the drone. So it means I need a controller. I'm gonna be showing a lot of projects and how these projects come to life. So what is in a project? And we can also maybe talk about it together, share some examples, and explain. So I just wanted to put this at the beginning so you can all understand why ROS matters and what ROS is all about. Now the basics. So this is actually not even programming, right? So I just wanted to point this out. It's in summary, basically the core concept, nodes in robotics and in ROS. You need to understand what is node, the concept of nodes. Can somebody tell me what nodes is about? You can just drop it in the chat. Let me see what comes to mind. I think you've heard of nodes. Yeah, the whole concept of nodes is popular. I know it's used in networking, it's used in different things. Does anybody know what nodes is about? You can just share in the chat or just raise your hand and I'll give you the opportunity to talk about nodes. Does anybody want to share? What is nodes? You can actually also ask ChatGPT, what is nodes? Just, I just wanted to get some feedback that you can hear me and you all understand what nodes is. Okay, so if I'll just wait a couple of seconds, maybe 5 seconds. Okay, anyone? All right. I would love active participation. I don't want to do talking. I want everyone to contribute as well. Okay, anyone? Nodes. All right. So node is more like a point for communication. That's what I think. So when I did yeah, introduction to applied electricity and sort of in physics as well, right? When you connect two wires together, it's more like a point, right, for communication, right? Maybe like a junction, like a node, right? So the different meanings to node. Node is a big word, right? But in ROS, node is like a basic executable process. So it means if I have a sensor, for example, I'm gonna if you know what a LiDAR is, you can just react. If you know what a LiDAR or an ultrasonic sensor, just react. Maybe use a thumbs up. Okay, nice. Thank you, John. Does anybody know what a ultrasonic sensor is? Anyone else apart from John? Or a LiDAR? I want feedback so that I don't really have to. Okay. Okay, Kelena. Oh, nice. Thank you, Kelena. All right. So we have the sensors, right? So for them to work, and communicate with other sensors or other devices, they need to, be able to form, kind of sort of be activated by nodes, right? So imagine you have a robot, right? So let's just let me give you an example, a drone. So a drone that has a camera. So for the camera to be able to communicate with us, the camera should have a node. So can you see the whole concept of nodes, right? So we can have as many nodes as possible. You can have a camera node, you can have a lidar node. So these are just basic executable process, right? It's important. So IMU as well. So for robot tracking, it can be anything. It could be your lidar, it could be your camera. Just having a node, right? A node is more like a point for communication. So, and most of the nodes are being built with C++ because C++ is, it's very easy to connect to hardware devices. All right, so maybe I'll just, okay, LiDAR, thank you. So, LiDAR, I think Cyril said light detection, sonar for, great. So these are some of the hardwares. So these hardwares need to have sort of like a node for communication, right? So you'd project without robotic project without having nodes. So like there has to be some form of network communication because ROS requires networking, right? When you go into hardware, you need to sort of communicate between maybe your computer and robots. So I'll show you maybe some little analysis with this and demonstration of this. I wanted to explain one note because if you don't understand this core concept, you might not really understand robot ROS and robotics in general. So you need to understand the concept of nodes. Now, so I think I've explained nodes. So now topics. So now, like I said, you have LiDAR, different sensors, sonar for sound detection. Thank you, Cyril. LiDAR. No, so LiDAR is not for light detection. Just wanted to point that out. So it's more like it's actually more for obstacle detection. So LiDAR, what LiDAR does is I'll show you what a LiDAR looks like. I think I have a picture of a LiDAR. So it's more like it sends laser beams, the depth for perception. Perfect. Yeah, so in the depths, we also have, we have different types of camera. So we have the RG and the RGBD cameras. The RGB are the normal color camera. So in the RGBD cameras, I've worked with an RGBD camera. So it has a laser beam in it that sort of measure depth. So for lidars are just basically for dynamic obstacle detection. So it rotates, 360 and send laser beams. And during the hands-on workshop, we're working with a lidar. Yes, so I believe that'll be interesting, and you will all see a lidar in simulation, and that'll be so cool. Then also there's navigation, some little projects we'll be working on. All right, so so this is 6:22. What? I don't know what time it is over there, so I just wanted to finish quickly so we can have more time for Q&A and hands-on. All right, so topics. So topics are basically, sort of what we use to communicate between nodes, right? So now I have explained what nodes are. So now we have topics. So when we say topics, we have publishers, subscribers. So a particular node can have a publishing topic. You can also remap it to become another type of topic. So topics are basically just are tags basically for a particular node. For example, LiDAR. So a popular topic in ROS for LiDARs are slash scan, right? All right, so messages, so subscribing messages. So messages are the data in the topic. So for example, in the scan topic for LiDAR, so what you can have in a scan topic, you have like numbers, kind of data format exchange. So I would explain this during the workshop, answering workshop. So we'll echo a topic. So we're gonna we'll do a roasted topic echo scan slash scan. So I'm just dropping some commands we'll be trying. Then services in action. So basically when you want to do something maybe in navigation, you can request, you can send a goal, you can, so raw services enables you this. Now we need two things in ROS. I tell people you need to learn some basics for C++ and Python. You might not be so good, but trust me, with ChatGPT, now you can sort of make sense of codes and sort of understand sort of how to program, robotics using Python and C++. But the two most popular languages used as Python and C++. Now, a lot of people are trying to use Rust to sort of, build security because, Rust is open source. So with Rust, you can sort of, you know, sort of protect your code when deploying for commercial use. But it's very important in this workshop that you know some native basics of Python and C++. But if you don't know Python, the workshop is very user friendly. You can actually follow through the guidelines, and if you face any error, you can contact me via my Gmail. All right. So moving to the next slide, I wanted to take a lot of attention on this so that you can all understand the basics, because the basics are actually what we use to build into the practical workshop. Now, simulation. Now, so in robotics, it's not good to jump into the hardware. You just say, "Oh, I want to build an Optimus robot, right? I think the one in Tesla, or I want to build a robot that dances." You don't just say, "Oh, let me go to the market, let me go to the lab and buy lots of components." No, you don't do that. What you need to do is you need to simulate it, right? So why do you simulate in robotics? So you simulate in robotics so that you can like reduce error, the chances of error in the hardware. Because in hardware you spend actual money, but in simulation you don't spend any money at all. Like simulation is right from your computer. So simulation is very important. You don't have to test with physical robots. You build, robotic application. You can build a robot in a lab and simulate it in your computer. So from my project, so I actually built a um vacuum cleaning robot that does disinfection as well. So and it can be used in restaurants, airports, and I actually posted on that on my LinkedIn. You can check it out later, and it was really really nice. So when I started the project, I actually used my school's cafeteria as a case study. So I had to design the cafeteria for the simulation and tested all my algorithms. So imagine if I jumped into hardware, I could end up damaging maybe chairs, the robot parts. So I could, spoil the 3D printed parts I use because I could make a lot of errors. So why do you need to simulate? So you need to simulate because you can build algorithms, in a simulated environment without fear of any damage to your robot or to the environment. So it sort of helps you to iterate, develop, build, test before deploying into hardware. It's very important you simulate in robotics. So the two tools very popular open source tools. It's Gazebo, very very important, very popular, and RV. So RVs is simply called ROS visualizer. So this is a tool that a lot of people use. Uh, Gazebo is not like the world environment, so it's more like what you're meant to see in real world, right? So you're simulating it. Then RVs is ROS for the visualization of the sensors and all of that. I'll be showing some of the projects some robots have built, and I'll show you what my lab looks like at my school. All right, so this is my school cafeteria. Yeah. So this is the simulation in Gazebo. I built this. Now you see those beams. You can see from the robot. This one here. So it's the LiDAR because it's static now because we are in a presentation form, but in the video form you see that the LiDAR rotates. I wish I had the GIF here, so I can share maybe during the practical session. I have a video to show you. Yeah, very, very, very nice video to show you. So the robot moves. As it moves, it avoids the obstacle with the LiDAR. Now, so this is another robot that you can also very popular robot. It's a mobile robot. So you see what's in front of it. It's actually a LiDAR. So the LiDAR is meant for obstacle, avoid as a delivery robot. So this is the simulation of a delivery robot in the US. So this is what RVs looks like. So I know this doesn't really look so neat. It's a lot of information, so I have to like explain. I know, but trust me, when you start, you get to understand first. So you see that the different topics you can be over there currently visualizing, and there's different frames. There's the TF frame, the point cloud, and we'll do a ladder. So we'll all do this together and see it. Like so this is my project. I was able to work on this. I did a SLAM. So SLAM is simultaneous localization and mapping for the robot to be able to move by itself autonomously in my school's cafeteria, and it was successful. I got about 95% accuracy working on this project. So hardware and prototyping. So we've discussed, simulation, what ROS is about, the basic frameworks of ROS, and what languages you need to learn to, delve into ROS. So Python, C++. We talked about nodes, publishers, topics, messages, and all of that. So this is the name of the project I've worked on. So this was my first ROS-enabled project. It's called ZBot. It's actually a vacuum cleaning robot. And there's a drone, the two drones. I work on two drones that are powered by ROS. And there's a few of what my life looked like at school. Yeah. So basically I have, if you want to get the slide, I was able to link it to some repos you can actually learn and practice and develop some of these things. I made it open source so you can just try out. So there's a very popular package in history in robotics is the potato ball package. I think this is one of them is the waffle. Yeah, this is my robot and this is the potato ball packages. You can just click on it and you'll be able to see it. All right. So materials and so when you want to develop, sort of hardware, because I didn't want this to be just simulation. I wanted to discuss in case anyone's interested in building a robot, maybe a mobile robot. So you need a camera for perception. Good. Like I think somebody shared that as well. Okay, depth for perception. You need a camera. So camera, what do you mean by perception? Trying to make sense of the images you're seeing. So sort of building computer vision algorithms for the camera. Then this ultrasonic sensor for obstacle avoidance. Then this is a LiDAR. So LiDARs are good. LiDARs for dynamic obstacle avoidance, just like ultrasonic sensors. But the thing about LiDARs is that they don't stay in one place. When ultrasonic sensors just stays like it's static, it's just fixed. But for LiDARs, they rotate 360. That's why they're used because they're very flexible, robust. Uh, you know, so you need a motor controller driver. I know a lot of people use this. It is you need a Raspberry Pi for so in simulation your simulation you'll be using your laptop. But now you'll be deploying ROS on an hardware. So you need a Raspberry Pi for building this. Then you need a motor controller and a motor driver. So application of ROS, I dropped a link where you can see some of these robots. They're very popular robots in industry, currently being used and being powered by ROS. Very popular. The Clear parts. There's the Scarf robots by Boston Dynamics, and a couple of robotic arm, and some projects I also worked on. You can get Totobots, and just check it out. Okay, so getting started with ROS, so you need, like I said, just re-emphasizing it. So you want to go into ROS, you need to understand Gazebo, to understand some languages like Python, C++. You can also learn MATLAB as well. So I worked in MATLAB when I was in Senegal. That was my first time into programming robotics with MATLAB, although I've used MATLAB for mathematical modeling and simulation. But MATLAB is good, but it's easier to just use Python and C++. MATLAB is commercial software. You can really, really sort of automate links and processes with MATLAB, but for the workshop, we'll be focusing on Python and C++. We're not going to code anything, basically. We're going to be running existing packages, and I'll just be explaining, what a ROS package looks like during the Aston workshop. Now, I know it's a lot of, I'm not call it jargons here, but I just wanted to show something, right? In robotics, if you want to get into robotics, you need to get your hands dirty and you need to start working, hands-on, and you need to sort of be ready to debug codes, right? And errors, right? So like you're gonna face a lot of errors. Trust me, errors. You just be used to like expecting errors because robotics is very, very challenging and very interesting and fun. Trust me, it's gonna be very, very good. All right, so the practical session. So we're gonna be having the practical, but before then, I just want to take short Q&As. If you have any Q&A. So I'm gonna share a repo for the project. So I'm gonna drop it now I'm gonna drop it now quickly on the chat. There's a repo I built for this webinar. But if you have any questions, just drop it in the chat, and you can sort of raise your hand and ask if you have any question. Does anybody have any question? So let me just send this now. So I actually sent it as a pre-material, but I'm going to drop the link here. Do I use i6 Sim? Yeah, I've worked with i6 Sim, but Gazebo is very easy to use, so I stick to Gazebo. But with the NVIDIA, you can generating models with Isaac Sim. So Isaac Sim is a good tool. You can actually just unmute. I would love to hear your voice. Kind of what's video the one talking. Please don't be scared. Just unmute. Just to confirm, Professor Barry, do they have permissions to unmute, or you have to give them permission? Okay. Dr. Barry, are you there? All right, so I sent the link already on the chat. I think you're muted. Let me see if I can unmute you.
Do you need me, Samuel?
Yeah. So the participants, can they speak?
They can't speak. Who can't speak?
Okay. All right. Does anybody want to say anything? Do you have any questions for the
Yes. Do you
introduction?
use Isaac Sim? John asked. John is asking, do
Oh,
you use Isaac Sim?
yeah, I do. I already responded. So Isaac Sim is open source
Okay.
as well. Yeah. Well, I prefer to use Gazebo because it's easier and more flexible. Yeah, Isaac Sim by NVIDIA, with the Omniverse functionality, I use it. But I prefer to use Gazebo because everyone in the community, in the ROS community, uses it, so it's easier, more flexible to run. Yeah.
And you may want to also talk a little bit about your pre-work, assuming some people here did not do the pre-work. Is there something that they are missing because they didn't do their pre-work?
Yeah, so basically we just need everyone to have ROS 2 on board. If you have ROS 2 on board, you're good to go. Let me just take a quick can you set up a poll, or I'll just ask everyone to react. If you install ROS 2 on board on your computer, just react. Or you can just drop in the chat. I have ROS 2 on board, or just react now. Just thumbs up. Anyone? Does anyone have ROS 2 on board on their computer, or Jazzy, any version? Oh, John, thank you. You have ROS 2 on board. Does anybody else have ROS 2 on board? So I just dropped a link. I should have done that at the start of the workshop, so you can just quickly do it. But after the workshop, just follow me. Trust me, it's going to be very easy to do, and I have the best way of installing ROS. You don't even have to do uploads. You don't have to use VS VirtualBox. You don't even have to use a version of it. You can just use VS Code. I'm gonna let you know what VS Code is. I'm gonna let you know VS Code, Visual Studio Code. If I don't have a GPU, you can actually run Rusty without a GPU. Trust, you can do it. I would send you. Okay, so if you check the link I sent, there's a popular extension on VS Code. So it's Rust2Env by Shakespeare. You can actually install it. So I can just quickly demonstrate that quickly. So let me just open the VS Code. I think it's on already. So I'm going to share my screen. Can you all see my VS Code? Let me just confirm. Can you all see VS Code on my screen?
Yeah, sure, we can. I can from my end though.
Okay, thank you. All right, finally I can hear somebody speak. All right, so that's good. All right, so what you need to do is just go to extensions. All right, so and just type Rust2Env env. So it's a one-click install. You install the Rust and you would be able to run Rust2 on VS Code. Very simple and straightforward. Then in the resources as well, I sent you the guidelines. So I'm going to go through it. I'm going to go through the repo with everyone. To the right away. Just drag my screen over there. Can you all see the repo? You can fork it. You can star it. So just give it more star. Perfect. Thank you, Jones. You've seen the repo. So perfect. So you need to set up your computer. What you just need to do is just follow this. I recommend you just use this. Installs ROS and everything you need, all the libraries you need automatically. So just install Docker first, install VS Code, follow the repo by Rust2Env. Once you click Rust2Env, you see all the instructions you need to follow. But you don't just need to watch this video. I think there's a video you can watch. You just click on the step-by-step installation video. All right. Then let me see if I can play the video. Let me see it. And to see if I can skip this YouTube ad.
Make sure you share sound if you share the video.
Yeah. Okay. All right. I'll do that. But you can all just because of time, I want to take more questions. So just follow this. Maybe we can just give a little bit of time because I know we close in an hour 30 minutes. So we still have like an hour max. Does anybody have a question? Let's interact. So let's give time for people to install the VS Code quickly. So you need to install the Docker. Just follow these steps, and we're good. And after that, I know for today we'll be running the Mobobot package. It's an open source package I built with a couple of my friends. Um, by Samuel Agba is a roboticist in Nigeria. He's one of my mentors. Okay, can you kindly share the link to this online version? Okay, Samuel, what version? Is it the Rush 2 environment? No, you can just unmute Samuel. How can I help you just quickly? Do you mean the Rush 2M? Do you need any help with that? Okay, let me send it to you quickly. So it's over here. So just go to Rush 2M. I'll send it to you now. So what you need to do is just okay. So here you go, Samuel. Shak by Shak here. So before we start, we'll start by 6:42. Answer workshop. So how many of you have Rush 2 on your computers at the moment? Does anybody else have Rush 2? Kelly, now do you have Rush 2 installed? Does anybody have Rush 2 installed? But if you don't have Rush 2 installed, it's fine. Open to consultation. You can all see from my computer. I really thought the pre-workshop materials would have helped, but I think a lot of people had issues. But maybe what we can do is we can do it together. Yeah, we can try doing it together. So first step, let me just just take it with you guys. So I put this together. Just make sure you start the repo. I've sent the link already, but let me send it again. Let me just copy chat. Drop the link again. Yeah, so that's the link. All right. So the first thing you need to do is okay. This is so if you really want to go into robotics development, and I advise you to do robots, and I dropped a YouTube video for that. But that would take so much time. That would take about 2 hours. But for these, it can take you like 15 minutes to set up Rush 2 on your computer right now as you're joining this webinar. So the first thing you need to do is, so we'll use the option 3. Option 3 is the fastest one. So you install VS Code using the link. So anyone wants to follow me, so download VS Code. Once you install VS Code, you need to install Docker and sign in and follow the repo. So you don't need to follow the repo. I think that might confuse you. What you just need to do is go to VS Code. Now install Rush 2M. Once you install Rush 2M, that's all. And just do Ctrl+Shift+P, start create environments. Once you create an environment, select the environment you want. So, can you all see my screen? Can you see the VS Code environment? Just to confirm, you can all see it. Thank you, Jones. You can see there. So you see Jazzy, Humble, Ion. I think Qt. They're already testing Qt. So Qt is the latest distro for ROS. Everyone is trying to test. It's still undergoing beta testing, but the most stable one, I think, the EOL end of life for Humble is about 2029. So Humble is widely used by a lot of developers. So Humble is very stable. So let me just give you some little history. So Rust 2. So why do we have Rust 2? So the first ROS we ever used was ROS 1. So a lot of it was nice. We had a lot of with the feedback from the community, the Open Robotics team and the interesting team to develop the Rush 2. So we set out. I think there's Noetic. So now we have Humble. There's Jazzy. Jazzy is the most recent one, but the Qt is the most updated one that's undergoing testing. So I recommend anyone going to Rush use Humble. Humble is very stable. You have little errors when you use Humble. Trust yeah. But then errors, like I said, expect a lot of errors. But trust me, with AI and with Stack Overflow, there's also ROS Discourse. I'm active on ROS Discourse. My email is in the slides. I'll share. I can just do that right now. Let me see if I can get the slides. Maybe Dr. Barry can help share the slides. There's a link to the Google slide. I uploaded it already on the workshop resources. So you all can sort of use it. And
where did you say your slides were again?
Then it's also recording.
Samuel, where did you say your slides were?
I uploaded it.
They're on the Google Drive?
On the Google Drive, yeah. You can just share.
I went to look, but I'll look again and I'll put them in if I can find them.
All right, thank you. So you can put it in the chat. I can also check for it. So I think we can start. Anybody else have Rush 2 Humble or ROS Jazzy? Anyone? Samuel, do you have Jazzy or Humble? Any of the distros? Okay. Does anyone have ROS 2 installed? Okay. Okay. Before we start the hands-on, any questions about ROS? I can explain it. Give this a chance. You can actually unmute. We can, I can get a question. You can also leave in the chat. This is the time for Q&A. Before we go to hands-on, because hands-on is going to be very quick and smooth. The packages are installed, so you have nothing to worry about. So all you're just doing is testing the package, looking at how it works, looking at the scan, the topics, the nodes. That's what we're going to be doing. Any questions? Could be anything. Could be.
Yes,
Okay.
the
Okay. Go
question
ahead,
I would
Cyril.
like to ask is,
Yeah, go ahead.
yeah, so you mentioned installing the ROS2 MV extension. So
Yeah.
after you install the extension, do you need to install the any other package apart from that? Like
No,
based on what you said.
you don't need to do that. So after installing extension, do you have Docker on your laptop?
Oh yeah,
Do you have
Docker, yeah.
Docker? You have Docker,
Yeah, sure.
perfect. So all you need to do is now, okay. So if for anyone that also has ROS2 installed, so that means you'll be sort of testing what we're doing today as well, Serial. So just do Control Shift P. So Control, can you try it? Are you able to do that? Control Shift P. You can create environment. Can you see it? So when you click environment, you can click Humble. Once you click Humble, it creates an Humble environment, but you need to have high stable internet connection to, containerize the package. Once you click on Humble, just the name of it, and boom, you're good. But because I already have an Humble distro, so I just need to start mine. So mine is, I already loaded it already, so I just click on Load Environment. Then I'll select the one I want. So I have Jazzy and Humble installed, so I just click on Humble. Yeah. I think are you clear?
Yeah, I guess so.
Thank you. All right, any other questions before we move into the hands-on? So we're working with the Mobobot. So let me just go through the Mobobot package. Trust me, it's very, very fun. It's very similar to the TotalBot, and we try to make it easier to understand than the TotalBot. So it's more like a cheaper version of the TotalBot, and I will share a link in case you need to order the robot itself. You can actually order and ship it to your country. Let me just go through it. So this is the Mobobot package. Let's go click on it. Okay. All right. So I would explain each of these folders and what they look like, why we need it why it needs to be like this, what the ROS package looks like. So this is Samuel as well, Samuel Biagba. He's my mentor in robotics as well in Nigeria. We work together. So you can see it as gazebo, easy to work and build. So this is the Mobobot in action. It's gonna navigate autonomously. You can actually do this in your room, and this is a room somewhere in Nigeria, and it can do slam and navigation. So working with the actual robot. So for simulation, just go there's some videos to support you. So once you click on, you can check some of the YouTube videos we worked on. So it's powered by Raspberry Pi, RP LiDAR C1, USB camera, Open TV, then there's IMU as well. Then the good thing about this is we built the IMU, it built the IMU and also the auto driver. So it's possible to use. Perfect. Yeah. ROS2 branches, Humble. Yeah, exactly, Devin. Yeah, exactly. So the thing is, when I have some sort of some of job or contract, maybe a developer might be working in Jazzy. I don't have to format my laptop and install Jazzy again, so I can just sort of use the VS Code. I can run my code on Jazzy. I can run it on Humble. I can run it on, on Qt that's still better, and it works fine. So it's a very good tool. And the good thing about this is you might not really need a GPU because it's running on a container. So it means the container has already got the GPUs and all of that. So it's free and it's open source. So you can run on any, on any versions of ROS. So, and if you check the Mobobot for the simulation, the different branches. So the two branches, Jazzy, there's Humble. To support those of you that have Humble, so you're going to use the Humble branch. So because of running on Humble, so I always the Humble branch, but it's the same thing. So we have the structure Humble, then the Jazzy. So there are two branches. Popular, like I said, the most stable branches now in ROS. The distros they're quite used a lot as the Humble and Jazzy, but Jazzy is more recent than Humble. Humble is very, very, very stable because everyone has been using. Thank you so much, Professor Barry, for sharing the slide. So the slide's already here, so you can check it out. And if you have any question later, you can reach me out via my Gmail. I will drop it in the chat. So let me just drop that now, just in case anyone has any problem later. Very important. Okay, gmail.com. Okay, so Devin, I assume it could possibly be used on a Raspberry Pi. Perfect, perfect, perfect. Yeah, you can do this. Then another, but the best way, because Raspberry, you don't want to sort of cloud the Raspberry Pi. The best thing to do in Raspberry when you're installing ROS on Raspberry Pi is to actually install a Linux server. But if you have so much money, you can buy the Pi 5, or instead of even getting the Pi, you can get the Jetson. Yeah, Jetson microcontrollers are good. So perfect contribution, Devin. Yeah, perfect contribution. But I recommend you work with Linux servers. Just install the Ubuntu server. I can help you with that. You just reach me out via Gmail. If you want to build an actual robot, powered by Rust, yeah, I can help. So any other question before we move into the hands-on? It's gonna be maybe for like 20, 30 minutes. Then we have another time for Q&A. I want to get feedback and what you think about ROS. I just want to get some questions and how you find this setup for by Shaxi. I contributed to this because it's a very simple tool. A lot of people have had issues trying to understand ROS. So because it takes a lot of time, installing packages, you have to do apples. It's good to do apples if you're going into the hands-on core robotics, because when you're using the the environment when you're using the environment built by Shaxi in VS Code, you might have some issues. Maybe some packages are not installing right. So the maybe the branch isn't stable, right? Or the one you install officially from the workshop is more stable and more obviously, but it's still the same thing, right? But I recommend you, if you're trying to test packages, want to test a chassis package, instead of you installing chassis from scratch, you just go test it on VS Code. So VS Code is very good. So everyone uses VS Code, right? So even when you're programming in Rust, you use VS Code. So VS Code, imagine you doing everything right on VS Code. That would be so cool, right? So and that's why I shared into everyone in the previous resources. But if you didn't get it, I could still share that again before the end of the meeting. Yeah, if you have any question, you can reach me via my email. I'm very very active via my email. And so before we start, any other questions? So I can just start the answer on. And also ask you to follow me as well. Yeah. All right. So are we good? So let me just get thumbs up if we're good to go. Everyone, thumbs up from everyone. We're good to go. Just show that you're following. You can all hear me. Are we good to go? I need a thumbs up. Anyone, thumbs up? Okay. I think some people are trying to set up their computers. Don't worry, there's gonna be plenty of time after. Okay, I can see some people. Okay, Kayla. Okay, thank you. Sayil. Kelina, are you good? I know Kelina reached out to me. I said he must be here. So good, perfect. All right. So we start. If you don't get anything, please make sure you drag me. Okay, practical session. I'm gonna bring my VS Code in here. All right. So what we'll do is I'll try split my screen, and I'm gonna drag so I'm gonna drag a package. So split my screen. Then okay, drag this here. Can you all see my screen? Can you all see my screen splitted? Just to confirm, give me a thumbs up. Anyone in the chat, just put a thumbs up in the chat. Can you see my screen splitted? Anyone? Let me see. Okay, perfect. Okay, thank you for the thumbs up, Kayla. Oh, perfect. Thank you, Jones.
Yeah, sure.
All right. Thank you. Perfect. All right, so we'll use the okay, let me just go to my profile and check I think there's a repo there. I dropped it somewhere. Let me just check the repo. Okay, over here. Okay, it's over here. So just click on that. Okay, so I'm gonna follow this so you all see that I'm following. So I'm gonna start everything from the beginning. So this is the VS Code, for example. It's opening VS Code for the first time. Okay, so I'm gonna cancel this. Let me just clear out timing out so you can all do everything from together from scratch. All right, so PC setup. So after you've done the PC setup, maybe later in the workshop, what you need to do is so this is where we are. So we're gonna load so after you've installed the ROS 2 and you've installed your computer and social development software. So first thing we're going to do is to check our post-installation check, ROS2 version. So first thing I'm going to do is to, so like I said, for those of you using VS Code, we're going to load the environment. So when you load the environment, so it's going to ask me Humble or Jazzy. So these are the two environments I'm using currently. We're going to be using Humble today. So started. So can you see ROS2 environment Humble started? So and I can also open a GUI. So what do GUI mean? GUI means graphical user interface, right? So I'm just gonna open it so that we can like sort of see what we're doing. All right. So it's more like a desktop computer. It's more like you can see another like an operating system on another. So this is actually Studio. This is actually Linux. This is 22.04. All right. So if I press ls, CSRC is able to if I press CD. So CD means you're going back to the former directory. And CD means you want to enter a particular directory. So ls is you're listing out what's in the particular directory. So ls to the desktop documents and so the package you're working on. So the package you're working on today is Mobobot underscore WS. Then you can see over here what it looks like. Mobobot. So in Mobobot package, there's view install log. So when you build a Mobobot package, you have this up here. So I just want to explain that quickly. So in ROS, we actually have what we call ROS packages. So today, the two packages we're going to be using is the Mobobot package. So maybe what I'll do is I'm gonna so let me so that you all see that I'm doing it from scratch. I'm going to delete this because I've done it before. So I'm going to delete it again from scratch so you can all follow. So I'm going to delete this so you can all see I'm deleting it. All right, perfect. So I want everyone to follow. So I'll just another package I worked on. This is empty, so I'm going to delete this as well. All right. Okay, you can just keep. Okay, so I think it's the default ROS2 package, also workspace. But before then, we're gonna do something quickly. So we're gonna CD into the SRC into ROS, then we'll check the ROS2 version. So can you see? Okay, so I think I made an error there. So I'll recognize argument. So just to check ROS2. Come in. I think it's another code for it. Okay, but it's fine. All we can just do is once we clone into because we haven't built, so what we can do is we'll just do a cocon build. So we can cocon build into this package, zero package found because it's empty, right? All right, perfect. Successful, but there's no package inside. Perfect. Well, let's see if the Omako we run, version we run. Okay, so maybe that's not the code, so it's fine. Like I said, errors are about to happen, right? But I just quickly check when I actually just checked ChatGPT what's the code to check the version of ROS, but it's fine. Okay, so we're using the Mobobot package. All right, so let me just open a ChatGPT version here to help us in case we approach any error, right? All right, so these are the prerequisites for the Mobobot package. We'll be installing Cyclone DDS. So what you need to do is to just copy this and paste it. So what you need to do in CD, so just do this. So it's already installed. So I've already installed this before, so that's why it's saying 0 upgraded, 0 newly installed, and for sure upgraded. So let's just I like to solve every error. So let's just say let me try and hide my. I don't know if it's possible. I think it's possible. Yeah. So let's just tell ChatGPT we faced an error. We're trying to check for version and it was telling us there's an error. So okay. You copied it already. Oh, let's paste it. Let's see what. Okay, doesn't work because for CCLI doesn't support. Okay, version flag. So I think the actual command to use is ROS2. Okay. Okay, echo. Okay, this is the code to use. So if you let me just drop the code here in case you so I'm gonna now we're checking this out. I'll drop this in the chat in case anyone needs to test this. Okay, let me open Zoom. Okay, I'll drop this in the chat. Let me see if I can drop this in the chat. Okay, this is it. So Echo ROS distro. I think if we try this now, you should have let's see, Control Shift V. Humble, perfect. Can we all see Humble? So if you have this code, it means you've installed ROS properly. Humble. So I'm just I've dropped it in the chats. Okay, so now we'll go to the next step. So this is just to show that we are good and ROS is installed on this computer and into this virtual environment. Perfect. So you can see that I'm running an operating system, another operating system on my VS Code. So I could do this because of the extension I installed on VS Code. All right, good. So now, after doing the first prerequisite, Cyclone DDS, like I said, ROS uses Cyclone DDS. It actually uses DDS. So Cyclone DDS is just for fast implementation of. This is actually used in mobile robots because you don't want any signal issue. So MKDR means you're building a folder. So MKDR. So I just copy this. You can actually just copy. It works because I structured the code very well. You don't have to copy line by line. If you do it, it will work. So just let's paste it over here. Perfect. So you're successful. So now if you go back to the Ubuntu home, you see that this Mobobot. Perfect. And you built it. Now, so this is because I know the open source ROS teleop key is very funny and a lot of people won't be able to use. So we built a special arrow keys that enable you to drive your robots, amazingly on your computer. And we're going to demonstrate everything together. So, okay, so just follow the package. Well, I just want to show you that I'm going to use this throughout so that you can all try this later in your free time when the video comes live on YouTube. So the next thing is to just copy this as well. Like I said, I took my time. Very simple. Just copy paste, and you see everything work. All right, perfect. So install requirements is pip install. You need Pinot to run the package, so it's already existing. So everything is installed. So now the next thing is to so we've installed the teleop package arrow key. So arrow key means you're gonna drive the robot with your arrow key. But then I also built a package that you can actually control the robot with your joystick. Yeah, I built that as well. It's on my GitHub. I will send it maybe later. No, you can find it. I started on my GitHub. So if you have a DualShock controller that you want to test running the robots with a DualShock computer, you can actually try it later. So you can actually use a DualShock or maybe it could also be your what other controllers do we have? Any controllers basically. I built a script, a node like a script Python script that enables you to connect, controllers for controlling ROS. I just wanted to strip that in. But for this workshop, we're using our computer keyboard. Then if there's still time, I would connect my DualShock computer controller to the ROS. So, all right, good. So next step, so we're good. So we've installed the teleop package. So next thing is to build the workspace. So just copy this and paste it, and simulate install. Simulate install means you can edit and the code changes. Like you can actually edit your code and you don't have to build again, right? So that's what simulate install does. I'm gonna keep that in case anybody has any question. Then before I go install before we clone into the Mobobot package, I want to go to the Mobobot package together. So this is the code for the git clone, but let's just run it sometime. I'll run it because of maybe internet issues, But let's see if LB runs. Yeah, it's cloning into it. So I'm gonna look at the terminal just to confirm. Just give me a react. Let me see if I can raise this up a bit higher. I don't know if you can see my screen. I just want to be sure you see my screen. Okay. Can you just thumbs up if you see my screen? Thumbs up. Perfect. Thank you. All right, we continue. All right, so you're receiving object. So before then, we just look at the package, what it looks like. So it's over here. I think I put a link to it. So it's over here, Mobobot. So when you clone into it, is what you're actually doing. So for a ROS package, for a mobile robot, for example, what you need to do, there's the base control, the description of the robots there. Then so we have different folders here. So this is for the navigation. So I'm going to add just a branch. Let me go to the onboard branch so we can all see what the onboard branch looks like. All right. So it's the same thing basically, but the same structure. Then we have the sim, robot sim, Mobobot sim. So Mobobot sim is for the simulation, the model, the world. So we have different worlds. Well, in this, we're going to use a simple world, the empty world, room, the walls, simple world. So like a lot of world. There's a lot the models. So they're models are what's the world in Gazebo. The models used for the worlds in Gazebo. So let's see, 1%. I hope the internet is good. All right. So, but like I said, for this, you actually need a good internet connection so that you can actually clone the packages and you're able to build the packages well. I think my internet connectivity is a bit poor, but I believe before maybe in the next 2 or 3 minutes should be done. Okay. Maybe I shouldn't have deleted the package, but I believe it should work. I think it's moving. All right. Config, so you can see the configurations. Use what is the Gazebo bridge. All right, so the codes. I know there's a lot of folders, lots of structure, but trust me, you just have to take it step by step. I'll just talk through a basic thing that you need to all understand. So, description. What we call this is something we call URDF, Unified Robot Description Format. So URDF, it's like the first thing you need to do in building a robot. You have to have the description of the robot. So let me go to the robot description. You see the links, the material name below, see the Zacro, so it's just including the different sensors. So it's camera, sonar, different sensors, the joints, see the link, so everything. This is where all the links and the joints of the robots being described. And for the gazebo, the Zacro, so in robotic and in ROS basically, most of the files you use and building most of the ROS projects are in the Zacro files. So that's why you see robot XML, the Zacro. So just basically just describing the environment. Yeah. How many of you have been able to clone into the package? How many of you in this tab? Let me see if anyone is with me. I've been able to clone the package. Let me see if there's anyone that's been able to clone. Just react or a thumbs up. Anyone? Or we are still cloning? Is there anyone? Anyone? Okay. This might be a lot of work, but trust me, after the workshop, you can try running it. If you encounter any error, just try sending me an email or just message me on LinkedIn. I'll respond to it. All right. So it's still 1%. Or maybe I have to switch my internet. Let me see if that's what's solve the problem. So 15. So yeah, there are a lot of packages we need to. Let me see if I can switch quickly. Let me just turn on my hotspot. Okay, I think my internet, yeah. Oh, it's 100%. Okay. We'll just give it a wait. We'll just give it a wait. So we see an object. Maybe I can just take some time for questions while we allow the packages to, sort of low. So 53%. Fantastic. So it's moving. All right. So any questions, guys, from the steps we've all gone through? Any questions? Any questions? Any questions, anyone? Questions? Any questions? Let's just take a break. I know we've done a lot of things since, so let's take a break. Any questions? Anyone? Any questions? Any contribution?
Okay. Oh, okay. I think the question I would like to ask is regarding the ROS to ENV. Once it's installed on the VS Code, the extension rather. So, the time you asked that if you press Ctrl Shift P, it shows an environment with an arrow, right?
Yeah.
So if you type humble, you won't see. It's not going to show you anything, right?
So you don't have to type humble. You just need to select. So what can you see? You can see my screen, right?
Mm-hmm.
Can you see my screen? So if you click, are you able to create environments? Are you able to see ROS to create environments?
Okay, yeah, ROS to create environment. Okay.
Perfect. So once you click on that, then you now click on humble. So it installs humble for you. I think is that good? Are you clear?
Oh, okay. Yes, I saw it there. Yeah, you're right.
Oh, perfect. Just all right. Any other questions? So I think it's 53% objects are being received. Any other questions from anyone? Could be anything. Could be any questions. Trust me, there's no random questions. There's no bad question. Just ask me anything. I'm very open to answering. So this is your chance to get me to, talk to you. Kalina, do you have any questions? I promise to assist you during the workshop. Any questions, Kalina? I don't know if you're there. Jones? I know Jones has been following. Any questions, Jones? Okay. Let me see. Any questions, anyone? Okay. All right. Perfect.
So what are the ports to expose? Like if you were to click on the Humble, do you have a specific port you need to expose? Like do you have a number? You could just use any number to expose.
No. Just press enter. Use the default one.
Settings.
Just
Okay.
press enter. Yeah.
Oh, okay.
All right. Any questions? Please don't be shy. I can answer your question. You just go ahead and unmute. I actually want this to be very interactive, yeah, because I know a lot. ROS is you already said that ROS is very complex, so I want this to be interactive. If you have any questions, just throw it open, so I can just attend to it quickly while we allow our packages to load in VS Code. Any questions? Anyone? Kayla, Sayil, any questions? Jones, Devin, any questions? Feel free. Okay, no questions. Thank you. Kalina, any questions? Okay, no. Perfect. All right. Okay. Devin, what about you? Any questions? You need any clarity on anything? I just want to be sure you're following. I want everyone to be following. All right. So let's move. Okay, done. So you can see you can see on my screen, receiving object done, resolving delta's object. So it means we've been able to clone. So now you see in our workspace, what we have like this in this load, what you see like this, it's in our workspace now. I'll show you in RSRC. You see that in RSRC we have exactly this in Mobobot. Can we all see? That's everything here. It's here. So everything in this repo, it's here. So just follow the instructions in the workshop repo I sent already. So I'll just send it to just in case anybody missed it. I'm just gonna share this now. Yeah, I'm gonna update the ROS distro command. I think that was an error. Let me just even do that right away, so that everybody can try it later. So let me just quickly edit this one. I think there's an error here. Change it to correct one. I think it's correct code, echo ROS distro. Perfect. So just gonna push this, commit changes, commit. Perfect. All right. Okay. So perfect. So you see it's echo ROS distro. And then we've corrected that error. So I don't think no one's gonna face this error. So let's move on to the next step. So we've been able to call clone build. We've been able to clone the package. We're able to build. So now we're going to ignore some packages in the Mobobot package because it's for the hardware. So you're just going to add this touch. So touch me just add in a call ignore code, right? So let me see if I can just do this. Okay. Come in. Okay, let me just open a blank page. Okay, just drag this out. Make this full screen. New tab. Okay. I think this works. All right. Perfect. So why do we need to do touch call ignore? I just wanted you guys to know. Let me check the chat since somebody's dropping a message. Okay. After installing ROS2 and we install ROS to create Humble. Am I right? Perfect, Sayo. Yeah, you're right. All good. Thank you, Devin. Thank you for the feedback. I really needed it. Okay, no questions. All right, perfect. So we're good to go. So we're gonna run I'm sure we're all excited to test the package and see the robots move in Gazebo. Yeah. So then maybe later we can try using the Russia controller. Yeah, I give a note. So I'll show you the link to the package. You can try it later. All right. So running. So let's move. So the next step, just like I said, you don't even have to type this. So you don't need to type this commands one by one. What you just need to do is copy paste, and see them work. So just copy and paste this. So it's gonna run in okay. So CD first into the base, and touch code on ignore. So boom. So you don't need to worry. So you're not trying to. All this means just the package shouldn't build the base, and so the base package is for the hardware, or you're trying to work with the Mobobot hardware. And I'll share a link. If you need to purchase the Mobobot, it's very cheaper than the Totobot. Yeah, very much cheaper. There's less than $1,000. Totobot is about like $4,000, $10,000. Yeah. So So why did we do Mobobots? Because we know that ROS is very expensive, right? And like building hardware for with ROS is expensive. So we try to build a hardware package powered by Arduinos, and and we will interface it with ROS and see how ROS works, right? So today would in the demo, we're gonna see the topics. We'll use RVs, we use Gazebo. I'll show you around Gazebo. I'll also import models and I'll show you around RVs. I don't It's not easy to run all this in a crash course, but trust me, this workshop it's made to sort of grasp an intro of ROS 2 is, and you can try testing the Mobobot package and see that it works well, and you all be good. And if you have any error or if you face any challenge, ChatGPT is your guy. And if you're unable to resolve the error, just reach out to me via email or LinkedIn. All right. So next step is to seed into the Mobobot and ROS step is. So ROS step is very important. So what ROS step means is you're trying to install the dependencies that you need to sort of run a particular package. So you see that ROS step update. So then ROS step install from part of SRC, ignore SR and Y. It's just a command. So you just installing the package required in the SRC. So we'll just run that quickly. All right. So you see within sources, so just trying to go to the distros and trying to update the packages, the requirements, sort of we call them requirements for the package work well dependencies. Yeah. So you can see some ROS is already end of life. So skip end of life, hydro skip, distro melodic end of life. So noetic is. So in the ROS community, EOL means end of life. So it means we don't really use those distros again, like the noetic, hydro. Well, now we can see if you look at for add distro Jazzy, you see it's still active, so it's not end of life. So you see add distro Keystone, it's still active. You see add distro Umbo, it's active. But for the for things like Foxy's end of life, so nobody uses Foxy again. Nobody uses Arden. So the most popular ones you hear for ROS is Umbo and Jazzy. Yeah. So guys, all required ROS steps installed successful. Can you all see my timing now? Just to be sure that everyone is seeing my terminal. Just maybe react. Everyone, anyone reacts? You can see my terminal react. And also, if you're following React, let me see. Don't think anyone's reacting. Can you all see my terminal? Or can you all see my screen? Let me just ask that first. I think I have a repo and also my VS Code open as well. Can you all see my screen?
Yeah, sure. From my end, I can.
Okay. Can you see my terminal? Can you see end of life Galactic, end of life Rufi? Can you see that? In the I think the rights. Can you see it? Can you see that?
Yeah, sure. End of life. Eloquent.
Perfect. I want to be sure everyone's seen this so that we're all together.
So like all these ones are going to be end of life soon.
No, they're currently end of life. It's just showing that in history we once had Noetic. So because let me just tell you what happens. So for Umbo, before Umbo came to life, let me use the word life because we try to make it's more like a name in the ROS community. I'll share some names after the hands-on. So we had Noetic. So before Noetic we had Umbo. So because of the development in Noetic and sort of the errors and the problems in Noetic and contribution, so after having resolving Noetic, we now had Umbo. So that sort of contributions to Noetic led to development of Umbo. So now we can just abandon Noetic when you're trying to do a ROS dev. So it's just like it was Umbo. So Umbo is end of life. So when you do a ROS dev, you say skip end of life, skip end of life. But the ones that are current, like the Jazzy, Qted, and Umbo, and also rolling. You see that you see for the Umbo, you see add distro Umbo, skip end of life Hydro, skip end of life Indigo, skip. So that's just how it works. I don't know if you got that clear, Cyril.
Yeah, I get you though.
Perfect. Then have you been able to install ROS 2 now? ROS 2 Umbo?
Yeah, so it's actually still installing. Okay. Yeah, it's getting like pulling Docker image from Trio H.
Yeah, you're right. Yeah, you need a strong internet, but I'm very sure it will work. It will definitely work fine. And if you have any errors, reach me on LinkedIn or my email. All right, so we'll move. Next step is to install the dependency. So now we're going to do the final build. So this is where we can't wait to do Qualcomm build and we see successful in install packages. So Qualcomm build, so that's next thing to do. So Control Shift V, Qualcomm build Simulink install. So you see the package is starting, trying to Qualcomm build successful. So perfect. You see that summary six package finished. And do you know why it's 6 package? Because we did the touch Qualcomm ignore for the base package that we're not going to be using. Perfect. So next step. Now we can't wait to just source. So just source. So let me. Maybe I'm gonna have a special price to anyone that's following. Yeah, maybe shout out. Maybe a personal one-on-one session. So let me see who's gonna win my personal one-on-one session on ROS 2. You can tell me what. Okay, I'll ask this question maybe close to the end of the hands-on workshop, and I would love someone to unmute and an answer. I think there's some questions in the chat. Let me see. After installing ROS, okay, let me check. Do we have to install Docker before installing ROS? Yeah. You need to do that. Yeah. Perfect. You need to do that. Sayal, yeah, you need to install Docker first. So if you look at the step, I say install Docker. Install VS Code, install Docker. So you need to install Docker. Yeah, perfect. All right. So we move. All right. Next step. Now, so what we're doing now is to source. So I'm gonna explain the whole concept of source. So source is like one of the biggest code that every ROS developer uses. It's not big, one of the most common line of code that everyone should know. Source is just set up a bash, right? It's very, very easy. And the funny thing about this is that if I type SOU, let me give you some tricks and for developing to make development. If you press SOU and you press tab, it's automatically complete. In tab, install, set, tab, but so it's very, very important. So what does this mean? So anytime you run source install / the bash, it means you've initialized ROS, right? So it means ROS should be active in this environment. Very important. If you Qualcomm build, then you source. Source is very important. It means you are sourcing the workspace. What's the source for the workspace? ROS, and it's the ROS to humble. And I'm like, okay, here's another message. There are so many Docker. Can you suggestion to install? So I sent a link. So let me just let's help Sahil so that you can also follow. So I'm going to send Sahil, I'm going to send you the link for the Docker. So any recent version. So I'm just going to click on the Docker the link. So you can just copy. I'll just copy Sahil. Yes, so just go install Docker. So just download Docker desktop. So are you seeing the screen? So if you see my screen, I say download for. If you're using the Windows, you download for Windows. If you're using the Mac, okay, perfect. You're welcome, Sahil. I think I sorted your ish. All right. So we move back to the workshop. All right. Thank you for the question, Sahil. Also, anyone, if you're facing any challenge, just drop it. I'll accept it quickly so that we can move on and proceed. So we're not going to do any code. We're not coding. We're just testing, explaining structures so you can build and debug and write ROS 2 packages from your end at any point in time. All right. So thank you for dropping that question, Sahil. All right. So we'll move on. So where are we now? So we are going to source. I was mentioning about sourcing. So sourcing is very important. You need to source your workspace into your environments or the folder that actually you're working in. Very important. Now, so the TF. Who knows what TF is? Let me just throw that out. Someone just drop a chat. Thank you so much. You're welcome, Sahil. Perfect. Does anybody know what TF is? Does anybody know what? Just try. Anyone? TF. It's maths. Okay,
Transformations.
Perfect. Say it again.
But coordinate transformations. TF.
Transformation. Yeah. Go ahead. You want to say something?
Oh no, sorry. I was just answering your question.
Okay, transformations. So what are they used for? What did you learn about it? And what are they used for?
Right. Yes. So with regard to transformations, you have different coordinate frames. Like for example, in your robot environment, you're gonna have your an inertial frame, like the main frame that like you denote like motion, like your positioning, like that kind of thing for the robot. So essentially that generally is like a map frame or something along those lines. And then you also have the frame attached to the robot itself, which is the base frame. Yeah.
Perfect. Can we all give Devin a round of applause? Let's give him the clap emoji. Let's clap for Devin. He got the answer very right. Can we all clap for Devin? I'm not seeing the emojis flying around. Okay. I want everyone to clap. All right. Thank you, Kayode. All right. All right. So we're moving. Okay. So he explained it very clearly. So transform. So the robot has a geometry, right? And there are different sensors components attached to the robot. So you have the camera sensor, you have the lidar sensor, you have the tires. So there's a base link. So there's joints. So the transformation just have to keep track of the robot geometry and the different connections to the robot. And we're gonna visualize this. Okay, it's gonna be interesting, guys. So we're about to visualize. We're about to make our first visualization. So should we let's run the Robotics publisher. So just copy this and paste it. All right. So Robotics publisher publishes the different links and the different joints, the state in the robot. So you can see we have the base link, the camera, optical, all that. So which is on the robot topic. All right. So what I'm gonna do is let me try. So I'm gonna for in the VS Code. You need like 3 terminals. So in when you're running this on an actual ROS2 environment with the Dualboot or a VirtualBox or a workstation player pro or an actual operating system, maybe like the Linux, you install ROS. With the usual way of installing ROS, you might just have to create extra terminals via the maybe Terminator application. And I think there's also an application on the desktop. So what you can just do is you just need to open terminal. But for VS Code, you always use the Ctrl+Shift+P and open terminal. Another way you can also sort of navigate commanding as well is to let me try go to the browser. You can always come here, the Terminator. So you can see ls, cd. Let's say we're in Mobobot, ls. So currently we're in okay. So let's use this. I would want to use this so that everybody can follow and also see the terminal at the same time. So maybe I can cancel this. I can cancel this terminal. Maybe I can just minimize it, and we'll all use this terminal. And we use this terminal. It's automatically installed. You can install it on your Linux as well. So we're gonna split this terminal, or let's say horizontally, then vertically as well, so that we can all like multitask, parallel programming. All right, so the first thing we're going to do is, like I said, it's very important to plus your workspace. So if I do ls, so src, so just need to do source, install. So I can actually just close one terminal first, so that when I do a repetition, all the terminals are already sourced. So these are tricks I use to sort of program faster. So install setup bash. So I'm just gonna, since I've sourced this, if I split this, it's automatically sourced. If I split this vertically, automatically sourced. If I split this vertically too, so that I can like multitask, right? I needed to do this so that we can easily be flexible. All right, so let's launch this. The Robot State Publisher. Okay, so I think it's a different style of paste. Okay. Oh yeah, so this is one of the issues with this. So I think in the ROS env, they haven't been able to copy and paste into the ROS env. But if I was on my VS Code, I would have been able to do that. But that's fine. I think we can just do to minimize this. I think they're still working on trying to enable copy and paste. So I'll just go back to using the normal terminal. Yeah, which is fine. So all I need to do is do Ctrl+Shift+P, load open terminal, another one. So let me open another one. Yes, I need to do extra things and just to sort of work, right? So now we're in Mobobot. So I have to go to Mobobot. So I have to do ls, I have to cd first, then ls, Mobobot. Okay. All right. So okay. Cd, ls, Mobobot. Okay. No cd, Mobobot. Okay. All right. Perfect. So I also have to be. So we also have to, like I said, what do I need to do is source. Anytime I'm working on ROS package, I need to source. So that I know I have ROS running. Source install setup the bash. So then, like I said, you don't have to type all the time. Just press one key, then press tab. It auto complete stores. So we need to do. So we're not working on ROS. We're working on. So the name of the folder is ROS. But now I have to go to the Mobobot workspace. I have to use after there's a CD, then CD into Mobobot, ls. Alright, so CD. Okay, then CD in Mobobot, then stores install, set up the bash. All right, so perfect. So we're good to go. So we have like 3 terminals for any code we need to run. All right, but I believe maybe by next 2 months, 3 months, you should be able to copy and paste into the terminal directly. If we're going to use this, we'll have to be typing the code one by one. I don't want us to do that. Let me just cancel this. Those terminals. We have enough processing power. All right. So the first thing we need to do, let's just look at like I said, the ROS publisher. So what does this mean? It's just basically publishing the different basically I'll call them states or links in the robots. Guys, wait for the robot description topic. All right, so we're going to try something very nice. So we'll look at the topics available. We'll look at the nodes, available as well. So then next thing we can need to do is to sort of do the RVs. So we can like look at the transforms, just like David mentioned. Now see the RVs. Can you all see my screen? Can you all see the robots? Perfect. So we've been able to launch the robots. So let me just sort of so you're able to see the robots just kind of like tick. Okay, thank you, Devin. So you can see that the TF. So if I unclick this, it doesn't show again. But if I click it, you can see the different transforms. You see the frames, they're all enabled. So if I enable all of them, see how they look. See the wheel, the caster wheel in front, the first wheel, the second wheel. So what's RVs? We've got to know what RVs is. Let me see. We're following RVs. What does RVs mean? RVs. What does RVs mean? I know you'll be asking questions, so I'm gonna ask you guys questions now. What's RVs? Does anybody know what RVs is? Perfect, correct. Yeah, that's correct. Thank you for the answer. So RVs means ROS visualizer. So it's basically what we use to visualize sensors, TF, frames. So if I want to add if I want to visualize something by topic, I see the available topics I can visualize. I see so the ones that are available. But when we launch the robot in Gazebo in World, we're able to see more topics like the LiDAR, the scanner, all of that. So we'll see everything work, don't worry. We'll see the laser scan, we'll see the LiDAR, we'll see the LiDAR beams, So this is the TF, So you can see the LiDAR. LiDAR is on top. This is where it is, over here. I see. You can see the tree, the base link. So how everything works. So basically TF is just trying to say that, what are the transforms, right? The relative transform, the transformations from the base link, to the different sensors on the robot. I wanted to explain this because these are the basics that we almost get. All right. So let me just clear this. So if you want to close the terminal in Linux or in VS Code, the simple way to do is press Ctrl C. Over here, I can also press Ctrl C. All right. So let's launch our robot Gazebo first time. Launching robot Gazebo on the workshop. So you see I did everything from scratch, clone the workspace, everything works. And I trust you'll be able to do this sometimes when you're free. But before I do that, let me try let's still run it. Or let's see the transformation tree so that we can all visualize it. I wanted to do that so that we can all see what we mean by transforms. And just to explain something. So if I'm debugging it, if I'm actually want to debug and trying to see if I face any error. So one thing to do when you're building on projects is to ensure that you have a good transform tree. So you see that, let me try. Okay, so basically I think we can make the VS Code bigger now. So we all have the link to the repo. So we can always look at it from time to time. So I'll just drag it to my other screen. Okay, perfect. So now you see that, look at the different links. So you see recorded at time, this link. I see the base link on top. You have the chassis, the body of the robot, the caster wheel, left wheel, right frame, LiDAR, camera, IMU. Yeah. So this is very important, and ensure that it's working before you start doing navigation. Because if this doesn't work, you will not be able to do navigation and stuff. Yeah. All right. So I'll just say anyone that answer my questions from let me see, the most active participants or the most active. Let me make it 3. Those 3 active participants get a one-on-one session with me. All right, for anything about robotics and ROS. We can also develop packages together. Yeah. All right. So this is you can see the links on so I'm trying this open. So ensure you're active. I want to see everyone active. So I'm just trying this open. So anyone that's very active and is able to answer 3 of my questions, I'm gonna make it 2. So three most reactive. I already have 2 active participants. So I'm gonna try open again. So if you're very active, you'll get a one-on-one session with me. All right. So so let's close this. So like I said, TF is very important. Like I said, it's very good so that you can like understand transformations like Devin explained, the different related coding transformation to the base link or to the origin. So base link is like an origin separate comma 0. You can see the base link. Like when I click on the base link, the chassis, the caster wheel, left wheel and right wheel are all connected to the base link. And as the chassis, on the chassis, you can see the IMU on the chassis of the robots. We have the camera, we have the IMU, we have the LiDAR, we have the sonar. On the caster wheel, so on. Because left wheel, so we have the left rim. On the right, we have so this is all designed, right? And I wouldn't want to go into a design because that's more advanced. But I just want to explain because of a TF. All right, so let's close this and let's visualize our robot in Gazebo. I'm sure you're all excited to do that. So the next step now is to run our robot simulation. So we made this package very friendly, user friendly. Once you run the Gazebo packet, the Gazebo command, robot sim the launch the PY Python script that launches RVs and Gazebo at the same time. So when I run it, you see now. Perfect. So you see that everything is loading. I won't be explaining what you see in the terminal. There's a lot of processing, but I will explain maybe much later. But now I know you can see the robots already. However, you can see the robots. If you can see the robot react, maybe on just give me a thumbs up if you can see the robots. Maybe I'll go to the Gazebo environment and maybe make a big screen so that we can all see it. And I also want to go to RV so you can see what RVs looks like and what the main environment looks like. So this is Gazebo. Oh, Cyril, thank you. You can see the Cyril reacting. Anybody else can see the robots? Can you see the robots? Let me try zooming in so you can see the robots. Okay, can you see the robot, guys? Let me see. Can you see the robot? Okay, Coyote, thumbs up. Nice. Who else can see the robots? I only have 2 people seeing the robots. Who else can see the robots? Just wave, raise your hand or anything. I don't think I can see the robots. Okay, I think everyone can see the robots. Devin, perfect, can see the robot, perfect. So you see that in Gazebo is very, very, very easy to use. It's a world. So basically, the robot is meant to navigate. Now you see that we have RO, ROS, Mobobot. So those are the entities in the Gazebo environment. I see the sun. There's for lights, room is world, and glamping. I won't be going to the design of the environment in Gazebo, right? Let me see. Okay, stop the video. Yeah, perfect. All right. So, but then we'll be doing a lot, right? We're gonna drive these robots, guys, and I'm sure you're excited to do this. We're gonna navigate these robots with our arrow keys. All right. So, okay. So now, in the world, you see the robots with obstacles, just like in real world. Now, RVs is ROS visualization. Gazebo is like the environment for the simulation. So in hardware, you most likely not use Gazebo, but you most likely use RV because you need to visualize, see the sensors, get the data, mixing of the sensors, right? So, but now you see that what the robot looks like in the world, right? So it's a big wall with walls. The robot is there, just there. It's not doing anything yet. I'm gonna open RV so you see what RVs looks like. Right, I minimize this. Okay. I can see the chat is already going. Okay, yes, perfect. Yes, thank you for the feedback, guys. Perfect. Alright, so I'll be checking the chats time to time. Alright, so I think Kenny's trying to join. Okay, perfect. Let me try admitting him. Alright, so now you see that in RVs, how many of you can see RVs? You see that RVs, you see the LiDAR, you can see that there's something happening, there's some scanning, right? So it's trying to get the obstacle. So you see the camera, let me make this big so you can see that it's taking a video of one of the walls. And you see. Perfect. So in Gazebo Classic, back then, you see the LiDAR actually, turning. I can actually show you. Let me see if I can show you. Yeah. in one of my packages. I'll just show you what the LiDAR will look like, what the LiDAR does. Actually, how was it able to do this? Is because it's able to scan the environment and it's already giving me like what's the surrounding looks like in terms of obstacle. So because of, let me just quickly show you in the new version of Gazebo. So this is harmonic, right? And sorry, I think ignition Gazebo. Yeah. This is actually the ignition. There's more of the later Gazebo now. But back then in classic, you see the LiDAR actually, turns. So let me just show you. I can show you. For the image topic. So I'll show you something. So you see, if I click on add, 60 different topics are available by topic. See, there's IME, there's DevCloud, there's camera, there's joint, there's pose, there's LiDAR. So can you see what we said about LiDAR? /scan. So that's the topic. So /scan is the topic, right? But the LiDAR is there. And it's very important that for all this to have been worked, we have written some nodes. There's some backend code, all put together for communication, right? And I'll show you that as well, so that we can all understand. But for simulation, it's free. Everything, all the plugins are being done. You don't have to pay for the LiDAR. It's free, open source. You just have to connect the Gazebo plugin and automatically comes up. So the next thing we'll be doing now just to drive the robots around. So I'll just consider this. So you can see the odometry, the laser, the pose, and the camera. So these are some topics you can play around. And what we can do is, all right. So like I said, I'm also gonna show you something, guys. So you can see that the robot's actually sensing. So that you see that there's something going on. We're gonna echo the scan topic. So the command is simple. So what we're gonna press is ROS2 topic echo / so the name of the topic is scan. So press scan. Okay, scan topic now. So what can I do is ROS2 topic list, because I probably missed the topic name. Okay. So we see ROS2 topic list. You can see the list of topics. You have CMD file. CMD file is what we used to drive the robots with the arrow keys. Let me just quickly check if there's any questions so I can just talk about it. I want to be sure nobody has a question. Let me check. Let me check. Any questions? Okay, nobody has a question. Okay, we're good. All right. So you see that over here in the terminal, when I do ROS2 topic list, you see that we have CMDVL, we have camera topic, we have TF, like Devin told us. So TF is a very important topic. That's like the basic that we need. And ROS out, ROS output, robot description topic, and odometry topic. So odometry is what we use to track the robots. Yeah. Then joint state. And so now what we want to do is to we do have a scan topic, so we don't have the I don't think the scan topic here yet. It's probably so there's a scan topic where we remapped it. Like I said, you can also remap your topics. So there are different ways of doing that. You do that in when you're doing the LiDAR scan code. When you're trying to document the code, you're doing the description in the robot description form for the LiDAR sensor. You remap the scan topic. What we're gonna do is we're gonna echo the LiDAR /scan. So we're gonna do ROS2 topic echo / LiDAR /scan. I'll try it when you see that it's gonna give us some messages. We're gonna see the messages now. Can you see 0 0 0 0 0? Can you see 2 points? So you can see the LiDAR as it's rotating, it's showing us the different reading. So I'm gonna stop this so you can see the different values. So I'll just press stop it by Ctrl C. So let me attend. I think somebody just dropped a question. Let me just look at it. Okay, any questions? I have stopped from Docker, but I'm still facing the same issue. What issue are you facing, Sayo? I don't know if you can unmute, so I can attend to this. We're actually pretty much done, but I have to do the Q&A, and also I'll give my Q&A so that I gather you all got the workshop. Okay, maybe Sayo, just send me an email. We can look at it together maybe much later. I'll know the issue you're facing. We're going to drop a chat later. I'll look at it. All right, because of time. So next thing we're going to be doing, guys, is to drive the robots. I think that's one of the most interesting things we'll be doing. Drive the robots and sort of visualize it in RVs and Gazebo. All right, so RVs is here as well. Okay, I think Sarah just dropped a message. Okay, you dropped a chat. Okay, I'll check it. Let me see the error. I'm just gonna look at it now. See if I can attend to it now. I mean, Sarah. Okay. Oh, okay. Pulling from Docker up. Okay. Look image not locally found. Oh, you need to create the environment. Or what you need to do is, after the workshop, just restart your computer. After you've installed Docker, just sign in. Then you try it. It should work. It has not your system. When you install Docker, you need to restart. You have to actually restart your computer. That's what you're facing. I've faced an error before, so I hope that's such a problem. Yeah. But don't restart it because you're in the workshop. So after the workshop, just try to restart. It should work. Should have done this during the pre-materials. You're welcome, Sayo. All right. So we move on, guys. Where are we? So what I was saying the visualization. So now the next thing is to actually pretty much done. We're able to visualize robots in Gazebo. So we're going to try the robots using our teleup hierarchy. So the code is is actually in the. I'll show you guys the code is everything is to do to run all this. All this I'm doing is actually in this repo I sent to the in the repo I sent to the chat, but I'll send it again for in case anybody missed it. So I'll just drop it again. So yeah, say again. All right. So quickly. So currently, once you just run, move the robots around. So to use the arrow key, just run it. Trust me, this is very easy to do, guys. I don't expect anybody to have any challenge. Many time you're doing this. So if I run this, so now you see that the robot is gonna move. So let me try zooming in. So you see that the LiDAR scan. Let me try minimizing this so we can also see this side by side. Okay, like this. We're able to echo the scan topic. All right, so this. So if I move, you see that the robot moves. So because the speed is low, so we're going to increase the speed by, let's say, by 0.1. So let's use W. We do that. Then the robot moves. And you see, the robot moves. And you see the robot. If I see the robot move, raise your hand. So let me increase the speed much, and I'll make this big, so you can see the robots actually move. So that we're controlling the robots, guys. Wow, this is so cool. It's able to move, so and yeah, there are lots of environments you can test, and this is nice. And a much more advanced thing to do is to run navigation. I would be doing this. I'll be doing this for those that answer my questions, and I would have a one-on-one session, right? So you have to earn it. So I guess we're done with the hands-on workshop, and I would love everyone to just clap for yourselves for being able to, follow through. And I will go back to the presentation. Let me go back to the presentation. Yeah. All right. So this is so the navigation, all the algorithms you need to do for this are all in the repo. Trust me, you can follow through and be able to do it. And okay, so let me just try and see everyone participants. Make this full screen. Okay. Can you also see my screen? Just want to be sure. Can you all see my PowerPoint screen? As I conclude?
No. Yeah, we see practical session at the top with 2 maps.
Okay. Perfect. Okay, perfect. All right. So sorry. Can you see my screen now? Brina, can you see my screen now? Just go hope you can see it.
Still shows the same thing. Are you trying to show slides, or are you trying to show?
Yeah. I'm trying to show my slides now.
Yeah,
so
try to switch over. It seems like you haven't switched over.
Okay, let me share again. So I'm going to share my slide now. So we're going back to the presentation, so we can take Q&A, and you just move on. Can you see my screen now?
Nope, same thing. Oh, wait a minute. Go back.
Okay.
Go back. Errors. Well, flip again.
All right,
there you go.
Yeah,
Stay there.
Yeah. All right.
As far as the eye can see.
Yeah. So it's a meme, right? It's a meme in the ROS community, right? It's you face a lot of errors, but trust me, with ChatGPT and with the community. Okay, now obviously, thank you, Renal. So it's very, 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 very possible, and trust me, you're gonna face a lot of errors. But with the community and support, you're able to resolve the errors. And all right, but trust me, it's something you'll be able to achieve. Yeah, right. It's actually a meme errors as far as the eye can see. All right. So now in summary, right? So the workshop. So learn some little Linux. We did some CD, some LS, MKDIR, and learned a little bit of C++ and Python. Because we didn't even type any code because most of the codes are already done, just for you to try, practice, and you get used to it. And learn ROS. You need to work, right? All right. So find out what ROS is good. It helps bridge simulation and reality. So if you're looking at building a robot and you don't have the funds for it, or you're trying to build a proposal, a project proposal, you can actually simulate your project, present it to people, and get a grant, or you can win a grant. And with ROS, you can actually build a simulation, a working simulation, and working prototype for an hardware application. But it's a great entry point for robotic development. It's community driven. So all this in the slide, you see there's a link. You can actually join the ROS Discourse. I'm on ROS Discourse. A lot of ROS community development, over like close to I think 500K. So we're going to 1 million. And I'll be at Singapore in October. So I was selected as a scholar to attend the ROS Discourse. So no ROS Discourse, the ROSCon conference this October in Singapore. Yeah, and I look forward to seeing maybe any of you there as well, and also connecting with key industry leaders and and also to network. Right, so thank you. So any questions, you can reach out to me on X. That's my handle on Instagram. This is my email. Very very active. Send me an email. I'm sure Professor Barry can attest to it. I will respond to it. Then my LinkedIn. And this is my website. You can just click on it and you'd see it. Then thank you so much. I'm rooting for you.
Can we please all give Samuel a hand? I'm rooting for you. Thank you. I know ROS is a very, very difficult topic to teach. We've had several people over the years try to do ROS workshops, and just thank you so much, Samuel. And we just wish you all the best. Samuel is currently, once again, looking for graduate school opportunities. So if anyone knows of any, please share that with Samuel. Reach out via Slack, via email. It sounds like I heard Samuel say that he made it look easy, John. that he's going to try to do some individual help sessions. So thank you so much for sharing that. We do have more workshops this summer. Please either sign up, share it with your community, share it with your friends. We probably have about 5 or 6 more before the end of the season. And if you think of any graduate opportunities, I think Cyril and Samuel, they are both either fundraising for graduate school or looking for graduate school opportunities. So if you think of any support for either of them, please, please, please reach out. And thank you for coming. This will be recorded. It will be put on YouTube eventually, in case you want to walk through it again, try it again, share it with someone. And we appreciate you all coming out and supporting Black in Robotics in our mission to educate our community and promote diversity, equity, inclusion, and justice in robotics. And I'm going to leave Samuel, because we have 10 minutes left, for the final words.
Yeah. All right. So before I take my final words, I promised to select 3 active participants. I already have 2, so there's 1 more. So I just have like 2 questions. You can tell me. I'll just answer in less than 1 minute. Just tell me what is ROS to you in 1 sentence. What is ROS? Like, what did you get from the workshop? And so I would just throw it as 2 questions. If you're able to answer, then what is nodes? What is topics? What's the difference between a node and a topic? How do they work together? So does anybody want to go? So if you're able to answer, you get a 2 hours standing workshop, personal workshop with me, and I can show you how to build ROS packages. We can also work on advanced navigation and SLAM. So who wants to go? Does anybody want to try? Anyone? Just raise your hand and I'll give you the mic. So I already have 2 active. I'm sure we already know the 2 active participants. So we have Cyril and I think Devin. Devin was active. So I'm just looking for 1 more. Okay. Anyone wants to go? What is ROS? You can just put in ChatGPT and All right, so Devin, you want to go? Go ahead, Devin. Go ahead. Over to you, Devin. I think Devin was the first to raise. I mean, go ahead, Devin.
Yeah. So, to me, ROS is the middleware that connects all of robotics together. Essentially, like the brain, the locomotion, the perception, like it's obviously all together. Obviously, that wasn't just a single sentence, but hopefully that was good.
Yeah, that's good. Okay, and what's this node and topic? Can you tell me the difference between a node and a topic?
Yeah, so the difference between a node and a topic is that, well, essentially, a node publishes to a topic, and you can either publish or subscribe to a topic, essentially. But that's what a node would do. But a topic essentially receives messages and it communicates with all the different nodes.
Perfect. So okay, let me go. Okay, I think okay, perfect. I think we have another person. So I've gotten the 3 most active participants. So I'll get your emails from Professor Barry, and feel free to reach out to me, and I'll send you my calendar so you can schedule a one-on-one meeting with me. Like I said, I have Devin, I have Manu, I have Cyril. So there's a clap for everyone. So thank you so much, Devin. Let's clap for Devin, everyone. Thank you. So I'm gonna send you my calendar invite link so you can schedule a one-on-one session with me, and we would discuss and take it further. And if you're looking forward to working on any project that involves ROS, feel free to contact me. I'm very much available. And I would just say that it has been very, very interesting and challenging. And I'm grateful for this opportunity by Black in Robotics for giving me the platform to showcase my skills. I'm very grateful to Professor Berry. She responds to my email in like seconds. Yeah, and I'm looking forward to graduate opportunities. I'm currently applying to PhD opportunities. So if there's anyone, you can just send them to me, and I'll be grateful to have them. Thank you all. Thank you for joining the workshop. I think we are about 13. Thank you so much. I do not take this for granted. And if you have any problem with robotics in general, if you want to build a project, feel free to reach out to me. I can mentor you and advise you. I've built thousands of robotic projects. So, and I'm currently contributing to a lot of open source softwares and like robotic projects. So if you're working on drones, I've worked on drones. I've worked on cleaning robots, mobile robots. I've worked on, computer vision projects. So I've worked using YOLO. So if you have any projects you want to consult with me, just reach out to me, and I'm excited to take it further. So thank you so much, Professor Barry, and thank you, Black in Robotics, for this opportunity.
You are so welcome. And I assume Devin's question has been addressed, right? Because Devin's hand is still up.
Yeah.
Okay.
Oh yeah, he actually answered my question.
Oh, okay.
Sorry about that.
All right. You can lower your hand
Thank you all for coming. Be blessed. We have more workshops next week. There's 2 next week, so check them out. I'll send out emails. Bye-bye, everyone.
Bye, everyone.